Today we're not going to save. Today we're going to invest. Well, even though we'll still save a little by doing it ourselves, of course, like we always do.
Ah, okay, invest. That's why you were telling me about the inverters, right? So now with all the inventions and everything, we're gonna go ahead and get everything set up. The business, the company, and all of that, right?
I'm not ruling it out for the future because I've always wanted to do some kind of Kickstarter type project or something along those lines, and who knows if down the road we might end up creating a real product out of one of the inventions we show around here. But no, today we're going to invest in comfort, in the comfort of having an electrical system on the boat like the one in our home, so we can use any of those appliances we have at home that make life easier for us.
Comfort and convenience.
And that's where the inverters come in, and then you'll see what it is. Hello sailors, and welcome to a new episode of The Low Cost Sailor. In today's episode we're going to see how useful it can be to have a residential AC electrical installation on our boats. Well, or on our motorhome of course, since it's basically the same thing. An electrical installation that will allow us to use household appliances and tools on board, which in many cases will be far more economical than buying dedicated ones, and which above all will provide us with great convenience. So we'll see just how simple and safe it can be to set up a small electrical installation so we can connect to shore power whenever we're in port and run all kinds of the things we need. But we're going to go a bit further than that, and we'll see how, thanks to power inverters, we'll be able to run many of these same appliances when we're sailing or when we're at anchor. We'll go over the different types that exist, their basic operation, how to choose the one that suits us best, and how to connect all of this together. Well, at least how I've connected it all up on my boat, because obviously there isn't just one single way, and it's even possible that my way isn't actually the best, of course. Having an AC electrical system on a boat, once it's a bit larger, seems practically mandatory to me, at least if we have more than one battery, for example a house battery. If only so we can have a battery charger to keep them charged and ready for when we go out sailing, and a socket or two where you can plug in a tool when we're doing repairs on the boat at the very least. But when we already have cabins, a kitchen, and this kind of thing, we're going to start seeing our boats as a small apartment. And a domestic AC electrical system will allow us to have many of the comforts we're already used to in our homes. And why would we give them up? In my case, when I'm in port, I use the 220 volt electrical system quite extensively for a lot of different things. Obviously to charge and properly maintain the batteries with a good battery charger that allows me to charge the 3 batteries I have on board independently and keep them always ready for all those gadgets and contraptions I've got installed that run on them. I already spent money on that and I have a good one.
Without the teleprompter, you're nothing.
No? Well, I did it for you because I know how much you hate noise and the ringtone went off, so I have to put it on silent mode. If I manage to do it, I have to set it to Do Not Disturb mode. What I have to do there is, I spent some money and I've got a really good one from Sterling Power.
Sterling Power? Yes, that does sound pretty premium. What are you doing, spending quite so much money on something that's that expensive?
Well, in general, there are a few things. Mainly anything to do with high power electricity, where I usually make sure it has a more or less decent level of quality, since those are the parts that can carry risks of overheating, fires, and all that. I'm honestly more attached to my boat than I am to my money. When it's not power electronics, to be fair, the Chinese stuff actually works really well. I really don't have any complaints at all. Aside from the charger, which is very important for the shore power connection, I also power various other things, for example, the boiler, so I can have hot water on the boat, the dehumidifier that I always keep running, an electric heater for when I stop by the boat in the winter, and various different tools. Even a hairdryer, which is honestly extremely useful to have on a boat.
Useful for drying your hair, is that what you mean?
Well, it can be useful for drying other people's hair. But in my case, it's more for drying things, because on a boat there are so many things that can get wet. The drip that comes in through here, the one where you go out and the water splashes you, I don't know. And then you fix it with that. In fact, the other day I was filming some shots with the underwater drone and I had to take my dad to the hospital. Tight schedule. I'm running around everywhere. I was filming a few shots with the underwater drone, and then I was rinsing it off in fresh water. I filled a bucket with water, put it in, turned on the motor so the thing would spin, and then a jet of water shot out. So I got soaked head to toe. I had 10 minutes to get out of there fast. Well, the hairdryer really fixed up my pants, and of course, it's also handy for plugging in a kitchen appliance, like in my case, a little microwave, that whether I'm in port or at anchor, lets me do everything from warming baby bottles right away to whipping up improvised meals pretty fast. Of course, it also works for charging the laptop or the phone, and for running a regular everyday TV, basically a classic alternating current setup, an AC Type 1.
Kinda like AC/DC, those music guys, you know, AC/DC, right?
Well, yes, the truth is it comes from that.
Yes.
Like AC/DC. An alternating current installation will bring any comfort of home to your boats, RVs, vans, or nuclear shelters. We don't want to be discriminatory either.
Preppers are definitely our friends.
Preppers worldwide, follow our channel. It's worth it.
Certainly.
When I bought my boat, the electrical setup was ridiculous. A connector for the shore power cable at the stern of the boat and 2 outlets in the main cabin. One outlet was for a TV and the other was for plugging in the Lidl battery charger. There was no residual current device, no circuit breakers whatsoever, nothing. So my very first step, and the first thing you should do with an installation like this, was to make it a lot safer. At a minimum, you should connect a residual current circuit breaker and a thermal magnetic circuit breaker to protect your installation, because even if both of those are on the shore power pedestal, it's hard to know what condition they're in and whether they'll work properly.
This thing with the RCD and the circuit breaker, that's what trips, right?
The fuses.
The fuses. That's what I was going to tell you. These are the fuses.
Sometimes, according to some authors, the automatics. My generation, more or less. The plumb bobs. Your father's generation and mine, which before was supposed to be a lead string. They really were these little lead things that would actually melt. The RCD would be responsible for protecting us so that in case we touch a wire or there's a current leak down to ground, it trips so quickly that it doesn't end up being anything more than a scare. The circuit breakers protect the electrical installation, mainly helping to prevent the risks of overvoltage, short circuits, overheating, and other potential fire hazards. So those 2 components are truly essential. Right at the input, I have an RCD to protect my electrical installation, along with 2 circuit breakers that are split into 2 independent circuits. One for exclusive use for the things I only use when I'm plugged in at the marina, the battery charger and the electric water heater, and another for the rest of the outlets I have around the boat. From there, I have 2 completely independent lines. My setup has been gradually growing over time. First, I protected the 2 original outlets with those circuit breakers. Then I also added the battery charger with its breaker. While researching, I discovered that the water heater on my boat, besides being able to heat the water using the engine's heat, could run on shore power electricity, but it wasn't connected. And then I connected it on the very same line as the charger. I started out by installing a switch so I could turn it on and off whenever I wanted, but as you already know, I'm a bit of a nerd, so I ended up installing a sun-off Wi-Fi switch so I could turn it on and off remotely from home. And while I was at it, with an option it has to add a temperature sensor, I took advantage of it so I could make it turn on and off on its own at the desired temperature. I mean, I made it super modern. Of course, 2 outlets were way too few for me, and I put them everywhere. Some regular ones, others IP rated in the bathroom, outlets everywhere.
There are never too many outlets.
You can never have too many outlets. You always end up using a power strip.
That's right.
Finally, you'll remember that I mentioned in an episode that my shore power cable was stolen. The feline thief. That's it. It was when I decided to stop running the cable all the way across the deck and instead install a replica of the shore power inlet connector in the anchor chain locker so I could keep it closer and use a shorter cable that wouldn't have to run across the entire deck. That's it for all of this. Very simple to do, using 3-conductor moisture-resistant cable, which for the power you'll be handling on a boat, 1.5 square millimeters of cross-section will be enough. But if you want to be sure, you can use 2.5 to be safe. With this, I can now get my microwave up and running.
Well, please make me something to eat. Look at what time it is. My stomach is rumbling.
Yeah, well, no, today we're not eating. Today we're not eating. That's for another episode.
See you in the next episode. You're not going to feed me.
The little snacks that I slip to you at night under the door. And now we're moving on to the Inverters. We've already seen that it's really quite easy to set up an installation so we can connect to shore power and run our appliances and tools while we're in port. But what happens when we're sailing along or anchored out somewhere? How can we keep our system fully up and running when we're away from the marina?
Well, with more meters of cable, a long cable from the dock where you plug it in, you put a roller there at the stern that spins and keeps letting out cable. Of course, I've seen boats that do that.
And a lot too. They cross the Atlantic.
Well, that's it.
I suppose so. I'm quite sure it's so they can keep the hairdryer running the whole way. These cable layers, those ships, they're called cable ships.
Well, one of those.
It might be.
Maybe.
And besides, if the engine suddenly dies on me, I just grab the cable, pull it, and head right back home. I never really get lost. Well, I guess not. The solution is power inverters. Devices that are responsible for converting the 12 or 24 volts of direct current from our batteries into 220 volts of alternating current. For Americans, 120. Alternating current, the kind we typically use in our homes, has many clear advantages. One of them is that since the voltage is significantly higher, the required wire gauge can be much smaller for the same amount of power. I encourage you to remember our episode 30 about battery monitors, in which we clarified some of these concepts of power and current. Also, it's much easier to transport and convert between different voltages. It has noticeably fewer losses during distribution, and the motors that run directly on it are generally simpler and more robust. That's why it's the kind of power we use in our homes. That was definitely good for Tesla, who won the famous battle with Edison over distributing electricity to homes some years ago, but it has one very important drawback for our boats. It can't be stored directly in batteries. Our boat's batteries are only able to store direct current, so to get the alternating current we used when we were connected to shore power, we'll need some kind of device. An inverter that converts direct current into a sine wave with the correct amplitude that our appliances require. The earliest inverters that came on the scene produced a very good waveform, essentially identical to the standard utility power supply, but they were extremely inefficient. Basically, they worked by connecting a 12-volt motor to a 220-volt alternator and generating electricity in the same way that power plants generated. However, this approach is quite noisy and it caused major energy efficiency losses on the order of about 50%. Modern inverters have become fully electronic and are therefore much more efficient. The very first and most straightforward approach is to generate a square wave with the exact same power output. These types of inverters, and I think I have one around here, are very inexpensive to manufacture, and the waveform they generate is perfectly suitable for powering some resistive elements such as light bulbs, heaters, stoves, and other household electronic equipment like computers and televisions, which actually operate on direct current, but is obtained from alternating current through a switched mode power supply. But they do not allow their use with other types of transformers or tools that have alternating current motors, or almost any inductive circuit, which can overheat, operate incorrectly, and even be permanently damaged. That is, they're generally suitable for a computer or a phone charger, but not for an angle grinder or a drill or similar kinds of devices, nor for a microwave either.
They're not really suitable for big stuff.
They're not suitable for heavy-duty stuff. Really, they're not suitable for things that basically spin or have motors or use induction or things like that. They're suitable for what usually ran on DC voltage, and that, in reality, when we bring it home, has a transformer that converts from AC to DC. The next type, which is a little more expensive than the previous one, aims to address the problems of the square wave using what's called a modified wave, which is basically a square wave with a gap between the rise and the fall, or even with several steps. In the more advanced units, you'll see them labeled as a modified wave. These ones are already suitable for a much wider range of things, and they're generally safe to use with most electronic devices, and they can also be used with appliances and with AC motors, although they do tend to be a bit less efficient overall. With these latter ones, they tend to waste quite a bit more energy overall, and that wasted energy is usually converted into extra heating in the devices and unwanted vibrations that can shorten their service life. Finally, pure sine wave inverters are typically the most expensive, but they generate a sine wave that's almost identical to the power from our home outlets. They're the type you can use with virtually any device without any problems. So which one is the right choice for me then? Square wave ones are usually fairly small, inexpensive, and low power. If you already know exactly what you're going to use it with, for example, to run your computer's switching power supply, you can use them with a good amount of confidence, but they're not a very good idea if you want to run appliances or tools, or even like I do use one to replace the electricity for all the outlets where, in the end, people can plug in anything at all that you don't know about ahead of time. Modified sine wave inverters, particularly multi-step models, can nowadays be used with almost any kind of device, although they'll be less efficient with devices that have mechanical parts and they can affect some more delicate electronic devices, but they still offer very good value for the price. Finally, if you want to use them for pretty much anything, and you also want it to be reasonably powerful so it can run tools, microwaves, or hair dryers, my recommendation, without any doubt at all, is a pure sine wave one. I have one that's around 2500 watts, which lets me run just about anything, at least for the limited time the batteries allow. So you also have to keep in mind that it's not only about having a very powerful inverter, but also about your batteries being able to provide enough juice. There are many different ones, and they can be sized to the power you need, but always choose one that's about 20% more powerful than the rated power you require, so it handles the startup surges from tools and appliances well, things like that. I usually list the rated power and the peak power in the comments, and on our website I'll leave you some examples, which are the ones I like the most. It's time to install it. When installing an inverter, you should keep a few things in mind. The small ones, low power ones that are intended to be used with a single device, can be connected to cigarette lighter sockets. For example, this one has a cigarette lighter plug. It's one of the small ones, and you can place it next to the device. Powering things on a small boat might work, but if you're thinking about a permanent 220V setup, it doesn't seem like the most convenient option to me. For me, the best way to install an inverter is by integrating it into the same AC system you already use with shore power. In my case, I added the inverter by following a wiring diagram like the following. The inverter needs to be located very close to the batteries that supply it, because a lot of current can flow through the DC cables as soon as the power we're using increases even slightly, and otherwise you'd have to use extremely thick cables, so it's really not worth it. Almost all inverters come with their own built-in overload protection systems, which will certainly protect the installation without you necessarily needing to add separate circuit breakers, although honestly, considering the price they typically cost, it still doesn't hurt to install one anyway. The residual current device really can be essential, and it should be installed very close to the power source and connected to the proper ground. I used this video to help reinforce my setup and add a residual current device on the inverter's direct output, so I can be confident that everything is working properly and that I feel safe. Finally, if you want the boat's outlets to work smoothly and interchangeably with either shore power or the inverter, I would strongly recommend installing a selector switch like the one I installed. The selector will allow you to choose whether the outlets are running on shore power or on the inverter, or even to completely disconnect all the outlets for added safety. For example, when my kids are on board, the selector really needs a middle position where everything is fully off, because if you switch too fast, you could let a shore power voltage spike reach the inverter at its output and fry it, so it's better to use this kind that has either 1, 0, or the other. I'm leaving you the detailed wiring diagram on the website and in the video description. There's also the option to do it with an automatic relay-based switch, but you run a higher risk that, with a very fast switch over between the two, it'll get fried. And I also like to have control over what's going on at the outlet, so I can switch to that mode where I turn everything off. In the end, most of the time I have the inverter off, and the outlets and power off while I'm sailing. I think the time has come to make it clear that I'm by no means an expert in everything, and that there's a very controversial topic where I'm sure you can help me with your comments. It's about the ground connection, ground wire, earth reference, or whatever you want to call it, basically the yellow and green wire in AC electrical installations. In home electrical installations, it's very common to have a 220 volt single-phase system like the one we have in our homes. Nowadays, it's mandatory for 3 wires to reach every single point, outlet and device, neutral, live, and ground. The grounding of a house, building, factory, or whatever it might be, ultimately ends up connected to exactly that, the earth itself, usually by means of a metal rod driven down into the ground that makes very good, reliable contact with the earth. Its main purpose is to ensure that any current leakage can find a very low resistance path to flow away and safely dissipate into the ground, preventing harm to people and equipment by keeping those currents from trying to find other alternative routes that might offer lower resistance. I mean, so we don't get a shock. The official regulations on boats are that all the grounds on a boat must be connected to each other, including the shore power outlet ground, and connected to the metal elements of the hull and, through the sacrificial anodes, to the water itself. This is the official and overall safest approach. However, it can also lead to some fairly undesirable side effects when we're basically just sitting in the marina. For example, if our dock doesn't have a properly installed shore ground and your boat, through the sacrificial anodes, does have a good solid ground. In that case, other people's leakage currents can end up flowing out through our boat and gradually consuming our anodes. Or since we're submerged in a salty environment and connected through the shore ground to other boats' propellers, hulls, and similar metal components, it can create a kind of battery-like effect with those other boats, and small galvanic currents get generated through our propeller and our through-hull fittings. These small currents arising from tiny leakage voltages on the order of roughly 1 volt or less can slowly corrode our metals little by little, sometimes even rather rapidly. To protect and limit which metals are at risk of corrosion, the key is to have good sacrificial anodes, which will be the first to wear out and will protect the more noble metals. Very rapid wear of these anodes will let us detect that there are problems on our dock or in the installation with these types of currents, but as long as we replace them before they wear down too much, there won't be a big problem, because if we have all the metal parts connected to them, they're the ones that will wear out. Disconnecting the shore power cable's ground connection to the dock can help prevent some of these galvanic currents from happening, and in practice, as long as we maintain a strong, reliable ground connection to the sea on our boat, safety won't be too seriously compromised, but in reality, it still isn't the ideal solution. There are also galvanic isolators that we can install in the shore power cable's ground connection to the dock, and what they're specifically designed to do is prevent the flow of small, low-level galvanic currents while still allowing the proper flow of a major fault current. That is, when there's a big shock, it will still go through there, but if it's just a small leakage current, it won't pass through there, so we won't have those galvanic currents flowing through our boat. Another option is to keep the different grounding points on the boat more separate, but if they don't all end up having a low resistance path to ground, to the sea in our case, then safety can also be compromised. For me, the ideal thing is to do the installation according to regulations, put in a galvanic isolator if we see that our sacrificial anodes are wearing out very quickly. If not, there's no need, and in any case accept that they will wear out and have to be replaced from time to time, because that will be a sign that they are working and doing their job. So now we're going to use our new setup. The number of things we can install on our boat once we already have a setup like the one in our home is very similar to what we could put in a house. For me, the most useful thing it's given me has been installing a microwave to warm up bottles, food, and not have to rely so much on gas. The microwave, which is very easy to install once we have the electrical setup, is a very important piece for me on the boat these days. But other things, like an electric heater for example, are very inexpensive and let you be at the port on the boat at a comfortable temperature, and also, if you pair it with some kind of Wi-Fi controlled outlet like I have, you can even turn it on a little before coming to the boat so that when you arrive it's already warmed up, like in this case.
It's absolutely freezing out there.
Important, like in today's case, that before leaving work, 2 hours earlier I turned the heat on here. When we arrived it was really warm in here and awful outside. I also have to try one of those portable induction cooktops that I can probably set on top of the stove, and I can also cook in port.
Anyway, what do you want it for if you don't know how to cook?
Sorry. One thing is not cooking and another thing is not knowing.
Not wanting to?
Not wanting to, that's really it. Let's see, I cook. I'm probably the one who does the most cooking in my house, and I cook quite a lot. But on the boat, I'm usually in a hurry. Well, we really have no doubt that when we're connected to the dock's shore power outlet, everything is going to work just like it does at home. But what exactly can we actually do with our 2500 watt inverter? Well, we're going to test just how well various modern devices and tools really work with it. This is where I try things out. As you can see, it can handle just about anything. The real heavy hits aren't taken so much by the inverter as by the battery, which obviously when you ask it for a lot of juice for a long time has significant voltage drops. That's exactly why things like hair dryers or induction cooktops are generally more suitable when we're on shore, or if we have a really large battery bank that can comfortably handle all of these things. For use at sea, the microwave will be more convenient, since in just a few minutes it can take care of our meal, but that's it, and maybe we'll also feed Carlos. It will be for a future episode, perhaps not too far off.
I'm hungry.
Not quite that soon.
Where are you going with that cap, man? It's really not that cold. This isn't exactly the Arctic.
Sure, look, I've got my hands.
Come on, go on then.
An AC electrical system on a boat can provide a great many conveniences and comforts. Obviously, not absolutely everything about it is positive, since it also introduces certain risks that are typical of household electrical systems when they're near water, aside from the sometimes controversial issue of stray currents, grounding in the sea, and galvanic currents. By taking suitable precautions, following the official installation recommendations, and being willing to sacrifice plenty of sacrificial anodes, hence their name, we really shouldn't have any problem. And we can count on the safety and convenience of being able to use multiple devices when we're sailing or when the boat is in port, as if we were at home. It's worth it to me. And the possibility of having a microwave on the boat, along with other onboard comforts, makes family life on the boat much easier for me. Therefore, the number of times my family actually wants to go out on the boat, and the overall use and value I personally get out of it, that my health could ultimately end up being affected, just like with so many microwave-ready pre-cooked meals. It could be, although for now my test results say I'm still pretty healthy. I'm not going to complain. In any case, maybe the topic of cooking is something we should cover in another episode. Who knows? Well, I do know, but I haven't told you that yet. Thank you very much for your kind attention, sailors. I sincerely hope you enjoyed today's episode. If you did, please give us a like, subscribe to the channel if you haven't already done so, and click the little bell to receive notifications each time we post a new video. You can find information about this episode, about all our episodes, and about everything that happens to us on our website, www.thelowcostsailor.com. In any case, the most important thing is that you come back here in a week because there will be a new episode of The Low Cost Sailor.
There's one more thing, and there's another thing I'm really dying to say. We need to thank you so much for 10,000 followers.